This video goes over an example of doing a hypothesis test for a claim about a population proportion. Our null hypothesis is similar to what we've seen in other hypothesis tests, but the statement we're making is about the population proportion P. It's not a statement about the mean mu. So our null hypothesis says HO, that P is equal to some percentage. The alternative hypothesis is one of the three of P is less than that percentage, P is greater than that percentage, or P is not equal to that percentage. Since this is a P hat type of problem, our test statistic will be a z-score. Z sub 0, or Z observed, is equal to P hat minus P over sigma of P hat, which, if you recall, is the square root of PQ over N. Example 10 here. A botanist has produced a new variety of hybrid wheat that is better able to withstand drought than other varieties. The botanist knows for the parent plants the proportion of seed germinating is 80%. So 80% of our seeds will grow. To test this claim, 400 seeds from the hybrid plant are tested, and it is found that 312 of them have germinated. Use a 5% level of significance to test the claim that the proportion germinating for the hybrid is 80%. So we need to come up with our null and alternative hypothesis. Now remember that P is the proportion of hybrid seeds that will germinate. So what's assumed to be true here is that 80% of our seeds germinate. So our null hypothesis should say P is equal to 80%. Now, because we don't know anything at all about the germination proportion of these seeds, we can't speculate as to whether it's greater than 80% or less than 80%. We're just going to come up with our alternatives to say that it's not equal to 80%. So P is not equal to 0.8. Should this be a one-tailed or a two-tailed test? Well, because the alternative says not equal in it, it should be a two-tailed test. Now, what we have to do to figure out our z-scores is to use that formula that we started off with, and our formula uses a p-hat value. That value was not given to us in the problem. What we were given in the problem was that 312 out of 400 seeds germinated. So we have to calculate our own sample proportion, our own p-hat value, and that turns out to be 0.78. So our z-score, our observed value, turns out to be -1. Now, because this is a two-tailed test, the z-score I calculated was -1, but I also have to use the opposite value, the positive value here. So the area that I'm looking for is the area in this tail, along with the area over here in the right tail. We'll use our calculator for that. Choice 2, normal CDF, or if you're using Desmos, the normal distribution, it's going to ask you for the lower bound and the upper bound. One tail is worth 0.1587 of area. Now remember, we have two tails, and that's why I multiply by 2. So the p-value, the total amount of area, is 0.3174. To answer question E, do we reject HO or not at the 5% level of significance, I need to compare this p-value, 0.3174, and our alpha value, our level of significance. 0.3174 is greater than 0.05, and remember the little rhyme, if p is low, HO has to go? Well, our p-value is not lower than our alpha value, it's not less. So we fail to reject the null hypothesis. Therefore, our conclusion says there is not enough evidence to suggest the population proportion isn't 80%. We don't have enough evidence to say our assumption is wrong, and that's what we're always looking for. One other thing is the term statistically significantly different, or sometimes known as statistically different. We say that our results are statistically significant if we reject our null hypothesis. So in the previous example, we would not be able to say we had statistically significant results. Another way of thinking about statistically significantly different is that the difference between our assumed population mean, what we write in our null hypothesis, and our sample mean is so large that it cannot be explained by sampling error alone. There must be something else going on. Those numbers are way too far apart, way too different. On the other hand, if there is not a statistically significant difference, so in the previous example, we did not reject the null hypothesis, what we're saying is that our results are not statistically significant. In other words, the difference between our assumed population mean or proportion and our sample mean was small enough that we can explain the difference by sampling error alone. So in the previous example, our assumed population proportion was 80%, our sample proportion was 78%, and we say in a statistical sense, there's no difference between those two. They're close enough together.